All right, so the Week 1 Science ACT uh, warm-ups start with passage 1, and this passage is a passage that is called a data representation passage, and they're characterized by these big graphs, and there's very small amounts of text. So if you see this small amount of text here, we've got a little bit, and what we want to do is we want to start with the tables. We don't need to read all this unless we realize we have to. So let's look at the table, and we identify the variables. So table 1 is looking at light intensity, and it's got no units, and it's weekly averages. We've got 6 weeks going, and we've got 3 sections, section 1, section 2, and section 3. Let's look at the data. Section 1 is pretty high. They're in the 300s, and it's basically staying about the same. Section 2 are lower than that. They're much lower, 70, 84, 79. They're decreasing, it looks like, decreasing every time. And so we can just say this is decreasing. This one is 120, and that's a huge jump there. The rest of those are not as much. So generally a decreasing trend, maybe a little bit of a jump there, but that's not really saying much. This is probably our most important part. Let's look at table 2 now. And in table 2, we're looking at weekly average air temperature. And so we've got air temperature, which is in degrees Celsius. We've got our 3 sections. We've got our weeks 1 through 6. And let's see, we've got an increasing temperature here. So this is going in a regular order. This is a pretty high number, 21 degrees. That's pretty hot. These are all staying about the same, 19, 19, 19, 19, 19. These are all staying about the same, 18, 18, 18, 18. There's a 19 there, but it's not a very high 19, right? And then we got all sorts of 18. So this one is increasing. This is probably the one we'll want to look at. So let's look at question number 1. The highest weekly average air temperature. Highest air temperature. We need to look at table 2. And table 2 says that the highest air temperature is, well, I circled it, 21.13. But let's look at this question. 18.47 we know is not the highest, right? That's going to be a very low one. Then we've got this 21.13. We know that's the answer, but let's look at the other ones. 120 degrees. This chart that says temperature doesn't have 120. That's the one up here. So we know that that one's not it. We know that this one's not it because it's even higher, 314. That's like 3 times the boiling point of water. So we know that B is our correct answer. Let's look at question number 2. According to table 2, weekly average air temperatures. We're still looking at temperatures. That's table 2. They're recorded to the nearest what? So let's look back at our chart. We've got there's the tens place, the ones place, the tenths place, and the hundredths place. So the nearest 0.01 degrees is our answer. That's A. Let's look at question number 3. Now, question number 3 is a little bit different. All right, it looks at different graphs. And so what we want to do is we want to identify what's going on these graphs. And so we've got a plot of weekly average air temperature versus the light intensity. So we've got a table 1 versus table 2 kind of thing going on here, and it's in section 1. So we're looking at section 1 for this graph and this graph. So we should have a 19.68 at week 1 and a 289.3 at week 2, or at week 1. So we've got 289.3 and 19.68. So where's 289.3 on a scale from 285 to 315? That's going to be right about here, closer to 285. So that's going to be right here, and we can see that all of them are about 285-ish. You know, they're all kind of right in the same place. And where is 19.68? 19.68 is going to be closer to 19 or closer to 22. It's going to be closer to 19. So this one is right here. That's not it at all. B we can eliminate. This one is right here. That also we can eliminate. And this one is right up here. So maybe it could be that one. Let's make sure. We've got this one that looks like it's close to 19. This one might be it. We can estimate 19, 20, 21, 22. That looks like it might be 21. Let's just double check another point. So what's our next point? Our next point is at 20.12 and 305. So let's find 305. 305 is going to be, let's see, that's 15 and 15. So 305 is going to be over here somewhere. 305, and our point is 20.12. 20.12. those are there, but this one was really around 20, and so we can eliminate that one, and A becomes our correct answer. Let's move to number 4. In number 4, we've got several statements, changes in the weekly average air temperature in Section 1 during weeks 1 through 6. So Section 1, 1 through 6, air temperature, we're looking at Table 2. So let's look at Table 2. We've got an increasing trend, right? It's every single time it's higher, and it goes to the highest temperature there. So we've got A, weekly average air temperature increased, yes, but then decreased. So we can eliminate A because we know it increased the whole time. B, air temperature decreased. We know that this is not correct. C, the weekly average air temperature always increased. That's what it did. C is our correct answer. Now the last question, number 5. Suppose the efficiency of illumination is defined as intensity of light absorbed by the plants divided by the intensity of light provided to the plants. We have no information about those, so maybe we can read in the passage. Let's look at the passage and see what's going on there. And it says, a team of researchers constructed a greenhouse. We have average light intensity in arbitrary units and temperature. There's nothing in there about efficiency of illumination. So let's look at our questions. We've got, would one be justified in concluding that the efficiency of illumination was higher in Section 1 than in the other sections? We don't really have any information, so yes, it can't be our answer. And we've got here, C and D, no, because the amount of light absorbed by the plants was lowest in Section 1. We don't know that that's true. We really don't have enough information. And D says no, because the information provided is insufficient to determine the efficiency of illumination. So D is our correct answer.